everyone, Faisal here from SolarisKit. I'm currently in Ras Al Khaimah in the United Arab Emirates at the Rix's Hotel, where we've been commissioned to install a solar hot water system for one of the villas. So we've actually completed the installation and it's gone really well, and I'm really keen just to run you through the installation. So the first thing is the hotel got in touch with us because they've got solar hot water systems, but they're not currently working. And so those are the systems just behind me. So as you can see, we've got two flat plate collector systems. They're thermosiphon type, but the key problem with the systems installed is they're facing the completely wrong direction. So Ras Al Khaimah, we're about 25 degrees northern latitude. So ideally we want the solar collectors to be tilted towards the south, where they can get all the sunshine that they have in the UAE. But unfortunately, these panels have been installed in the completely wrong direction, and they're all facing due north. And it's unfortunately not just this system, it's a lot of the villas there. So there's another 4 systems there, and basically all the villas, as far as I can see, unfortunately have the same problem. So of course, with the solar collector to work, you really need sunlight falling on the solar collector, so it can convert that energy into heat. And if there's no sun, it's never going to do a good job. So it's actually just coming up to 1:15 in the afternoon, and as you can see, most of the panel is actually in the shade from the tank itself. So this panel is getting a fraction of the energy. And so I actually got a solar irradiance tool, and I measured, if I point it at the sun, we're getting about 1,000 watts per square meter of irradiance, which is fantastic. Pointing at the direction that the panels are installed, it is literally 1/10 of that energy. So yeah, not ideal. But it's good for us because it meant we had an opportunity to install a system that actually worked. And so over the last 2 days, we've been installing a pretty large system, heating one much larger tank. So we've got a 400 litre stainless steel 316 tank made by Solartherm Gulf. The guys are great in installing the tank, and we installed in total 15 of our solar collectors to provide a lot of energy to heat the tank before that check-in period of 3 p.m, typical of a hotel. So with our solar collectors, what we did is we connected 5 collectors in series. So there's basically 3 rows of 5, and we use a single manifold here. So you can see manifold feeding 1, 2, 3. That's the inlet manifold going into all the collectors. The water goes through the first collector, gets heated up to the second, third, fourth, 5th collector, and then it comes back into this pipe here. So that's our combining manifold, or an outlet manifold. And so that's how it's all hydraulically configured. Pretty simple. And like with all our systems, we use they're really easy to use push fit style components that you can see here. So it's nice and easy to connect the system, just push fit them all together, basically daisy chain them. And again, with the piping for the inlet and outlet manifolds, it's all 15mm piping, plastic piping, using push fit style connections. So we did everything with John Guest speed fit fittings. Obviously it's a little bit hard to tell because we've lagged everything, and Chris did a great job from our team in making sure we minimize those heat losses. Now, for the fluid to go through the solar collectors, we've just using a really small 12-volt DC pump, which you can see there. So the nice thing about our system is really low pressure drop in the solar collectors, which means we can get away with a tiny pump, which is A, low cost, but also really cheap to run as well. So that pump is actually only consuming 24 watts maximum of electricity. So the whole system is really economical to run. So if you want to compare it to a heat pump, for example, you know, in sunny conditions, our input is only 24 watts, and this system will provide almost 3 kilowatts of heating. So it's a pretty big COP if you look at it that way. But of course you need sunlight, but sunlight here is really not an issue. In fact, apparently it only rains a couple of days a year, so it's ideal for a solar heating solution. It's not going to consume anywhere near as much power. It's also not going to have corrosion issues, which of course is a big problem since we are so close to the coast, and it's going to be much quieter as well. Now, for the system to operate, one of the other main components is the controller. So this is the controller that we've got installed. All we need is 2 temperature sensors going to it. So one measuring the bottom of the tank and the other one going to the collector. And based off those temperature difference, the controller knows when to turn the pump on and off. And as you'd expect, we've got a flashing light, which means the pump is on and we're getting heat from the solar collectors to the tank. So it's doing exactly what it should. Our controller is IP67 rated, so totally fine to have outdoors. We installed it facing north, so just to keep it out of the sun as much as possible, the same direction as these solar panels. So as you can see, it's totally in the shade, which is ideal. And we've just fastened it onto some breeze block, which we've used to lift up the tank and keep it off the ground. And we've done the same for the whole collectors as well. So the system is working really well. When we started off the day, the tank was sitting at 25, 26 degrees, and we're already at 48 degrees, and it's coming up to 20 past 1. And we've got a couple of hours left of sunlight as well. So the system's working really well, especially for its first day. What we're going to do is install a number of energy meters, look at how much energy this system is consuming compared to the other villas as well. Obviously we're expecting a pretty big difference because all the solar panels are facing the wrong direction, but really useful to see how much energy we can save with our solar collectors. Now, in terms of benefits of our solution, other than the fact that we're not going to have the over temperature issues that flat plate collectors have, we're not going to have issues with hard water building up inside our solar collectors because of the material that we use inside the solar collector, the key advantage that we have, especially for a hotel, is the fact that our solar collectors, especially with this villa, is going to be virtually invisible outside the rooftop because the solar collectors are sitting below the parapet wall. So the parapet wall is roughly 1 meter in height. Our solar collectors are 0.5 meter in height, so they're all nicely tucked in. Obviously, it's not the same with the thermosiphon systems, which stick quite proudly above the parapet wall. So if I look to the other villas, you can see the solar hot water systems there. So if you could imagine all of these villas having a SolarisKit solution, you basically wouldn't see any solar hot water systems, and so that would keep the resort looking much cleaner, a lot nicer, wouldn't spoil these views. Because I mean, I can see the solar water systems on those far villas there. You probably can't see it on the camera lens, but they are certainly visible. So that's definitely an advantage of our solution, the fact that it is much, much neater. So hopefully that's been a useful video. If you've got any questions about installing our system, or you'd love to partner with us, please get in touch via the